Let's do a quick problem where we practice what we learned about all the scalar multiplication, addition, and subtraction. So let's start with this problem. I am trying to solve this problem for vector v. First thing I'm going to do is distribute this -2. And I can distribute the -2 to this component form vector using what we just learned about. All we have to do is distribute the -2 to the individual components. So -2 times 1 is -2, and -2 times -2 is a +4. Now, just so you know, this 0 with an arrow over it is the 0 vector. You can kind of think of it as like a point at the origin. Doesn't really go anywhere or do anything, but you can write it in its component form as 0, 0. Now, if I have 5v minus 2v, that's vector subtraction with some scalar multiplication thrown in. That's 3v. Now, if I want to solve for v, I need to get rid of this vector, which I can just do by subtracting. So if I have 0 minus a -2, that gives me a +2. And if I have 0 minus 4, that gives me a -4. And then I want to divide all the components by 3. To solve that, vector v is 2/3, -4/3. So we used some vector scalar multiplication in there. We used some vector subtraction. We used some more subtraction over here. So there's a lot you can do with all that scalar multiplication, vector subtraction, and addition. But essentially, you can just think of it in its components. Now, next vocab word. A vector in standard position starts at the origin. And you'll notice that when we put it at the origin, we have another right triangle, which means if I have my x side and my y side, if I wanted to find the magnitude of this vector, the length of this vector, I can use some pretty familiar equations. That gives me the magnitude. And if I wanted to find the direction of this vector, I could also use some pretty familiar equations to find the direction or the angle of this vector. So you'll notice this is vectors, but it's still nothing new. This is still trigonometry, where we're finding the magnitude, which is r, and the direction, which is theta. We can also then write our component form using some other very familiar looking equations, where the x component is r cosine theta and the y component is r sine theta. So here's a summary of all those vocab words. The magnitude is r. The direction is theta, which is the arctan of y over x. And here is how we write the component form. R cosine of theta for the x component, r sine of theta for the y component. Now, notice it does give you some new symbols. This little double absolute value sign is the symbol we use for r for vectors, for the magnitude. So just like how in chapter 6 we called it the modulus, and we use those absolute value signs around z, when we're talking vectors, we use double absolute value signs, but it's still found using the same equation. So with that in mind, let's try to write the component form of a vector that has a magnitude of 5 and a direction of 60 degrees with the negative x-axis. So let's graph this out. So I want it to have 60-degree angle with the negative x-axis. There's 60s. and I want it to have a magnitude of 5, aka an R, a radius of 5. Now, if I want to write this in its component form, I do R cosine theta for my x value and R sine of theta for my y value. Oops, forgot some stuff in there. And I can just plug these in. However, I do need to find theta from standard position. That's some pretty quick addition. I just do 180 minus 60 to get me 120 degrees in standard position. So that would tell me this in component form would be 5 cosine of 120 for my x value and 5 sine of 120 for my y value. And hey, look at that. I can simplify those because these are unit circle points. This becomes 5. Let's see, cosine of 120 is -1/2. Sine of 120 is √3/2. So this would give me -5/2, comma 5√3/2. And that is our component form of the vector. So the x value is -5/2, and then the y value is 5√3/2. And that's how we get the component form from the magnitude and the direction. Oops, dropped my calculator. So let's try another one. This time I'm giving you the component form, the x and the y. And I want you to find the magnitude and the direction. Now, you should be able to do this. Remember, the magnitude is just the R value, which you've practiced finding before, and the direction is the arctan value. So pause this, try to find magnitude and direction, and write your final answer like this. Pause the video, try that part out now. Let's check your work. Magnitude is the same thing as finding R, which we have found plenty of times by this point. I got 6. Direction is the same thing as finding theta. I saw that this tangent value is a unit circle, so I just plotted the points x, comma, y, and could tell from the unit circle that that is going to be 5 pi thirds. So I can write it like that with my magnitude outside the cosine and sine. Or you could write the magnitude inside with the cosine and sine. Just so you know, either of these answers would be perfectly correct on a test. So with that in mind, we only have 2 problems left in this lesson. Let's practice a little more with magnitude. In this first problem, I want you to find the magnitude of V, find the magnitude of W, and then do the magnitude of V minus 2 times the magnitude of W. See what that is. I also want you to take vector V minus 2 times vector W, then whatever vector you get from the inside of that, then find the magnitude of it. These problems are showing you that where you find the magnitude matters. These answers are going to be different. So pause the video and try finding both of those on your own using everything you've learned today, just to make sure we're all good to go, and then come back and check your work. Let's check your work on the first one. So I found the magnitude of vector V just using my R equation, got that to be 5. Found the magnitude of vector W using my R equation, got that to be square root of 5. Then I just plugged them into here, what we had. So I took the magnitude of V, which was 5, minus 2 times the magnitude of W, which was √5, and got my answer. Versus, if you look at B, I took vector v minus 2 times vector w. So I distributed that 2 in first to get this. Then I had vector v plus that, so that's vector addition. Just add the x and y parts. 3 minus 2 is 1. 4 plus 4 is 8. So that gave me this vector. Now I find the magnitude of it using my R equation to get square root of 65. So that's to show you that these two equations were very, very similar, but where the magnitude is changes the answer significantly. So basically, still follow order of operations even when you're dealing with vectors. And that is all for lesson 7.1. That's your vector basics. You now know what a vector is, how to find its magnitude and direction. You know how to write it in component form. You know how to add and subtract them. And you know how to find their magnitude and direction using our R and theta equations we've been using all semester. That's it.